Hey Ninja Warriors, welcome to yet another power packed session, and in today's session we are going to discuss differentiation, methods of differentiation. And specifically for your KCET examination, this chapter is amongst the high weighted chapter. Yes, I would say that this chapter tops the list of high weighted chapter, right? So we are going to start with the very basics. Differentiation we are going to start with derivative of standard function, what is a product rule, what is a quotient rule, how to apply chain rule. All these things we are going to cover in this session. Along with that, we are going to talk about all the PYQs which were asked from this chapter, from this topic in past few years. But before I start any further, do let me know in the chat box if I am audible and visible. Please confirm once that if I'm audible and visible to you guys. We are absolutely give me a green signal if I'm live. Okay, so I can see Kush Mohit. Good evening Kush Mohit. You are absolutely consistent and very regular, just like Abhishek, good evening. Please joining, and don't forget to like the session, right? Okay, all right. Yes. So what about the last lecture? Are you guys were able to follow the last lecture? You guys are understanding my sessions. You guys are understanding the concept. You guys are able to solve the questions of the chapter. Okay, yes, audible. Yes. And Puneet, it was you. Yeah, so Puneet was asking a doubt from the last lecture last night. So Puneet was asking a doubt specific to continuity, and I guess Puneet is understanding. Thank you Puneet for joining. Indumati, Kush Mohit, all right, keep joining and keep coming, keep liking my session. And also for all of those who are new to the channel, who are coming to this my session for the very first time, you can have a look at the brief introduction of mine. So my name is Namrata, and I have over more than 10 years of teaching experience in both online as well as offline, and I have taught and mentors various students. Some of them are actually studying in top colleges of India. Okay, all right, yes, all right, I guess we guys are absolutely fine. You guys gave me a green signal. So now, without any further ado, without wasting any time, let's start with the topic today. Okay, so let's start with, first of all, see, in previous lecture what we have seen limits. What is the limits? We have solved a few problems on limits. Then we jumped on to continuity. So we tackled what is a continuity, how to tackle problems on continuity. Then we have studied differentiability. Now after differentiability, here comes the differentiation chapter, and we are going to start with derivative of standard function. Derivative of standard function. So there are some standard function whose derivative you all should remember no matter what. And you know what, this is going to be helpful in your physics as well. Okay, so Shreya sir will also point out that did Ninja ma'am teach you this? Did Ninja ma'am told you about derivatives, right? So one concept, but it is helpful in your physics and mathematics both. Okay, and also I believe that you guys are aware about these formulas also, but let us have a quick recap about this formula. So first thing, if somebody asks you what is a derivative of a constant function, d by dx of a constant function, d by dx of a constant function, that is d by dx, k is nothing but a big fat 0. So any constant, right? So suppose if I ask you derivative of 2, so derivative of 2 is what? 0. Derivative of pi, can anybody tell me in the comment section, derivative of pi is what? 0. Okay, all right. Now second, derivative of d by dx of x raised to power n. So derivative of x raised to power n will be n x raised to power n minus 1. Okay, third formula right here is d by dx of e power x. D by dx of e power x. So d by dx of e power x is e power x, and there is a joke about it. So d by dx of e raised to power x. So e raised to power x is something which is sigma male. Okay, this is a Gen Z term, by the way. Sigma male is something that he doesn't get affected. Okay, so e raised to power x is like that. If you differentiate, no difference, like he'll not get affected. And the function e raised to power x, and if you integrate as well, now e raised to power x is going to become same. Okay, all right. Okay, now the next formula is d by dx of a raised to power x. D by dx of, can anybody tell me, a raised to power x? That means 2 raised to power x. So d by dx of a raised to power x will be a raised to power x log of mod of a. And the last, fifth formula right here is d by dx. Okay, let's not write it here. No. Hold on. No. Okay. Then now we are having the next formula. Let me draw a line. Let me take a shape over here. Yes. So, okay. All right. The next formula on your screen is the fifth formula, which is d by dx of ln mod x. This is going to become 1 upon x. And what is ln? Ln is something which has base e. Ln is something which has base e, right? E means Euler's constant. Now again, same thing. If d by dx of log of x to the base a, what about this? So this is going to become what? See, watch it. So this is 1 upon x ln a, my dear students. 1 upon x ln a. Okay, this is the formula. Now the seventh formula is d by dx of sine x. D by dx of sine x is what? Cos x. And the next formula is d by dx of cos x is nothing but minus sine x. Okay. So can you see that here you can see where there is one trick. Whenever there is co over here, can you identify the co over here? Can you identify the co over here? So whenever there is a co over here, there will be a negative sign. Whenever there is a co, there will be a negative sign. Okay. Alright. So this is the 8th formula, sine and cos. Now we need to add one more page for the next next set of formulas. So the 9th formula will be d by dx of tan x. And the 10th formula will be d by dx of cot x. The next is going to become d by dx of sec x, and 12th d by dx of cosec x. Cosec. Okay. Alright. Derivative of tan x is what? Tell me, derivative of tan x is tan x sec x. Okay. Sorry, derivative of tan x is sec square x. What about derivative of cot x? This is minus cosec square x. Are you understanding? Are you understanding the trick I told you? Whenever you see over here, can you see this co? Co is spotted. So whenever co will be spotted, there will be a negative sign. What about derivative of sec x? Now derivative of sec x is sec x tan x, and derivative of cosec x is minus cosec x cot x. Okay. So these are the formulas that you have to remember. Yes? Clear? Perfect. Yes, Bindya. Yes, Kushmohit. All right. All right. Okay. Now, let us just understand some theorems on differentiation. These are the formula that you have to understand, remember. But we'll solve the problem. On the way also, we are going to remember some problem. Now, theorems on differentiation. Theorems of differentiation. Okay. Theorems on differentiation. So first theorem says, if you are having any function f of x and if you are having that constant k, okay, and if you wish to differentiate this, so now dy by dx will be equals to d by dx of k fx. So this k is what? Constant, and whenever you spot any constant inside the derivative, you can take that constant out. So this constant will be out now. So this will become what? K d by dx f of x. Now derivative of fx is what? K f dash x. Okay. So suppose if I just give you an example. that y is equals to 3 sin x. So how will you differentiate, ma'am? Okay, dy by dx is equals to d by dx of 3 sin x, correct? Now 3 can come out and you just have to differentiate the sin x. So this is going to become 3 cos x and you are done, right? Got it? Yes, give me a big thumbs up if you have understood this. All right, clear? So next theorem on differentiation, shall we move on to the next theorem of differentiation? Now next theorem of differentiation looks like this. So suppose you are having sum or difference of two functions, y is equals to either fx plus gx or y is equals to fx minus gx. Now if you have to differentiate it, okay, let's differentiate. So this is going to become dy by dx equals to now d by dx of fx plus minus gx. Okay, so now the derivative will get inside. So derivative of fx plus derivative of gx. Okay, so derivative is distributive. So this is going to become d by dx of fx plus minus d by dx of gx, correct? So this is f dash x plus minus g dash x. So dy by dx says that f dash x plus g dash x. Let us take an example. Suppose this is x plus sin x. Now can you just tell me how to differentiate it? Dy by dx will be 1 plus cos x. Simply, right? So this time I have done it directly. This time I am doing it direct thing. Can you see over here? I am doing it direct thing this time. Okay. All right. Getting it? Clear? Absolutely perfect. Shall I move on to the next theorem now? Next theorem is all about product of two functions, right? So suppose you are having y is equals to fx multiply gx. Fx multiply gx. Now this is something which is very important. We are going to call it as product rule. Product rule, okay? And we are going to apply this clearly. Okay, now product rule says that if you have to differentiate dy by dx, then what you have to do is you have to keep the first function constant, okay? So fx is as it is, but the second function will be differentiated plus this time gx is constant and first function is differentiated. This is what your product rule is. Now I'll be giving you one example on product rule and you will be telling me. Suppose you are having y is equals to x sin x. So now solve with me, solve along with me. Okay, are we ready? So this is your first, this is your second. This is your first, this is your second. dy by dx will be what? Tell me. So this time, ma'am, as per the formula, first function will be kept constant. Derivative of sin x will be written over here plus. This time, sin x will be kept constant and derivative of x will be written over here. So x multiply derivative of sin x. Tell me, derivative of sin x is cos x plus. Now this time sin x is constant but derivative of x will be 1. So you can just clearly write this x cos x plus sin x will be the answer. Are you getting it? Yes? Clear? Just let me know. Absolutely, Kush Mohit, you're absolutely right. X cos x plus sin x. Okay, got it? Yes, are we good with product rule? Let's now talk about the quotient rule. Now this quotient rule is something like product rule is everybody's favorite, but whenever somebody sees quotient rule, he'll be like, oh, no. Okay, so quotient rule is something that you have to remember. Okay, now quotient rule, y is equals to fx upon gx. So dy by dx will be equal to, dy by dx will be equal to, yes Bindya, okay. Now dy by dx will be equals to, now denominator will have the square of second function. Suppose this is your first function, this is your second function. So to differentiate there is a formula. So denominator will have gx square, okay, and in the numerator gx will be kept constant and f will be differentiated. Second function constant, first differentiated minus first function constant, second is differentiated. Okay, so here you have to be very careful about, like, first term mein there is second function absolutely as it is. The first function is differentiated. Okay, gx as it is, f dash x. Let us understand with the help of example. Okay, let me give you one question right here, my students. One question, okay. Y equals to x upon sine x. Yes. Okay, are we ready? Are we ready to apply? Yes, Abhishek. Are we ready to apply this quotient rule? Okay, let's start. So dy by dx. Direct, I am doing direct, okay? No mercy, no mercy, no step by step, because hello, this is not a PUC midterm session or PUC board session. No. This is a KCET session, so you have to understand that here we can skip the steps. Here we have to understand that we can do some steps mentally, right? So now the second function will be in the denominator sin x square, and sin x will be kept as it is. Derivative of x will be 1 minus. This time x will be kept as it is and derivative of sin x will be cos x. Getting it? So finally your answer will be what? Tell me. Sin x minus x cos x upon sin x square. Getting it? Yes. So we are right now doing elementary problems to understand the formula. Once we are done with all the formulas, once we are done with everything, then we will be switching towards KCET PYQs. Okay. Yes, Kush Mohit, absolutely, you are absolutely correct. And now this is the quotient rule. Let me just write quotient rule. Oops. Quotient rule. Okay. Perfect. Cool. Now the fifth thing is chain rule. Chain rule. Chain rule is used when you have composite function. Do you know what is a composite function? Anybody in the chat box? Tell me. What is a composite function? In the chat box, guys. Okay, ready? So how to differentiate f of g of x? How to differentiate f of g of x? This is a composite function. Understand that the chain rule says that always start differentiating from the outer function. What is the outer function right here? What is the outer function right here? F. So dy by dx will be equals to f dash. So outer function is differentiated and the internal function will be kept as it is. We are not differentiating. This is not f dash g dash x. No. Only the outer function is differentiated. Internal function is as it is. Now, multiply. This time you have to differentiate the internal function. What is internal function? Gx. So, derivative of gx is g dash x. Hold on. It's still there. We are still there. We have still not finished. Now, you have to differentiate one more internal function. So, one more internal function is x. So, derivative of x is 1. The moment you will get 1, you have to stop. Okay. Alright. Now, I know that this chain rule is a little bit on a trickier side. So, you must be thinking, ma'am, please give me one example. We just want to try. Okay. So, let me just give you sine of log x, my dear students. Okay. Do it. I'm here. I'm right here. Sine of log x. How will you do that? So, obviously the internal function is sine and the outer function is log, my dear students. Okay. So, dy by dx will be derivative of sine is what? Ma'am, derivative of sine is cos. And the internal function is kept as it is. Log x is as it is. Now multiply. This time, can you see g dash x? G dash x. That means we have to differentiate log x, d by dx of log x. So I am just being a little bit lenient and I am just trying to write down that we are differentiating log x. But otherwise, while solving the KCET problems, I am not gonna do that, okay? So this is the derivative of log x is 1 by x, right? So cos of log x by x. Yes, Kushmohit. Yes, Abhishek. Yes, Puneet. I guess you guys are like pro. Now you have become pro in derivative, huh? You have attended Shreyas sir lectures on derivative or what? Huh? You guys are surprising me. Okay. Okay. Now let me give you one question. I guess you guys are like what I felt that you guys are pro in it. So let me give you one challenging question to you. Are we ready, Kushmohit? Huh? Let me give you one question which can be quite challenging to you guys. Okay? Okay. Chalo. Before that challenging question, let's do some like small elementary problems so that you understand what we are trying to do. Let's do some elementary problem. Now the question time. Theory is done. Trust me, theory is done. Now are we ready for the problem? Grab the notebook if you don't have right now. Okay, so I'm giving you problem. First problem. Just tell me. Y equals to root x plus x raised to power 3 by 4 minus 3x power 4. Just differentiate it right away. Second, you are having second problem I'll be giving on the next page. Okay, this is like elementary problem, not the challenging one. Let's wait for the challenging one because I want you all to solve that challenging problem. I don't want to give you like right in the beginning and you'll be like, oh, okay. I just want to drive you like that. Okay, elementary problems are done so that there are less chances of making mistake. Okay, all right. So now this is root x dy by dx. Okay, so first of all, y is equals to what? Root x is x power half plus x raised to power 3 by 4 minus 3x power 4. So just tell me dy by dx will be what? So do you know x raised to power n derivative is what? Tell me. Ma'am, n will come in front, power n minus 1. Okay. So this is half will come in front, x half minus 1. Plus 3 by 4 will come in front, x 3 by 4 minus 1 minus 3 into 4, x 4 minus 1 is 3, correct? So this is 1 by 2. X raised to power minus half will be this, 1 upon x raised to power half. 3 by 4 x raised to power 1 by 4 minus 12x cube. This is your dy by dx. 1 by 2 root x plus 3 by 4 x raised to power 1 by 4 minus 12x cube. This is your dy by dx. This is your final answer. Yes? Yes. Now Abhishek is telling me something which I was about to tell you. Okay, so one thing you guys have to remember because it is going to help you a lot, which is this. Derivative of root x is 1 upon 2 root x. This you can directly write. Okay, a few steps you can just directly skip. So remember this. Remember result. Remember this result. Derivative of root x is 1 by 2 root x. Yes? Understanding this? Okay. Make a note of it. Make a note of it. Alright, clear? Shall I give you the next problem, guys? Okay. Next problem is this. Y is equals to e raised to power x, x square plus 1. Now differentiate this. Find dy by dx. Find dy by dx. Now I'm not gonna help. Okay. So let's start. dy by dx. Now the product rule will be applicable. E raised to power x will be kept as it is. Right? X square plus 1 will be differentiated. So x square plus 1 derivative is what? 2x plus. This time x square plus 1 kept as it is, and derivative of e raised to power x is e raised to power x. Oh, derivative of x raised to power x is sigma male, remember? So let's start. dy by dx. Now the product. Okay. E raised to power x. Alright, dy by dx. Now your answer will be what? If you take e raised to power x common, you'll be getting 2x plus x square plus 1, and hold on. This is e raised to power x plus 1 whole square. Yes, Puneet, absolutely right. You guys are absolutely right. So, I guess this is also clear. Shall we move on to the third problem now? Are we ready for the third problem? Yes? Yes, Kush Mohit? Ma'am, can't we apply product rule? Yes, Bindya, product rule. We are applying product rule only, if you remember. So, this is your first function. This is derivative of second plus second function as it is and derivative of first function. Do you notice? So, dy by dx will be what? First function constant, derivative of second plus second constant, derivative of first. Done. Okay. Yes, Bindya? We are doing the same only. Now, third question. Are we ready for the third question? Y is equals to x upon 1 plus x square. Okay. Start solving. Now, quotient rule. What is quotient rule? Quotient rule says that the second function will stay in the denominator. The second function will stay in the denominator, 1 plus x square whole square. Basically, the square of, let me just write it down, f of x, g of x. D by dx will be equals to what? G of x as it is square, gx as it is, f dash minus f g dash, like that. So now 1 plus x square will be kept as it is, and now derivative of x will be 1. Derivative of x will be 1 minus, we are having this time f, the first function is as it is, and derivative of the denominator will be 2x. So this is 1 plus x square minus 2x square upon 1 plus x square whole square. So 1 minus x square upon 1 plus x square whole square will be the answer. Right? Got it? Yes. Okay. Let us increase a level a bit. Are we ready to increase a level a bit? Yes. Let us increase some level. Let us do some more practice. Okay. Yes, Puneet, absolutely right. Okay. Now, find the differentiation. Find derivative with respect to x. Y equals to square root of sine of 2x plus 3 plus x square ln x. A little bit complicated, but the straightforward question, but still a straightforward question. This is not at all a tricky question. No, I would not say this is a tricky question, okay? Okay. Y is equals to root sine 2x plus 3 plus x square ln x. Okay, now dy by dx. Chain rule will be applicable. Understand. Do you know what is the derivative of root x? Ma'am, derivative of root x is 1 upon 2 root x. Okay. So, derivative of root sine 2x plus 3 will be 1 upon 2 root sine of 2x plus 3. Chain rule. Okay. So, root is done. After root, what is that function? Ma'am, sine is that function. Now, this is your function. Now differentiate this function sine 2x plus 3. Now again, this is again composite function. Sine 2x plus 3 is again a composite function in itself. You have to differentiate it. Okay. So sine 2x plus 3, what is the outer function? Sine. So derivative of sine is cos of 2x plus 3. And now the internal function. So 2x plus 3 will be differentiated as, derivative of 2x plus 3 will be what? 2. Now we are done. At least this derivative we have done using chain rule. Okay. Plus, now what about this? This can be done by a product rule. X square ln x. Okay ma'am, product rule will be applying. X square is kept constant. Derivative of ln x is 1 by x plus. This time ln x will be kept constant and derivative of x square will be 2x. So finally what you're going to get is dy by dx will be equal to, can you see this 2 and 2 are getting cancelled out. So cos of 2x plus 3 upon root sine 2x plus 3 plus x. See, x square by x will be what? X plus 2x ln x. This is your final result, my dear students. Can I check? 1 by 2 root sine 2x cos 2x 2. Okay, plus x square by x plus 2x. Kush Mohit, where is log x? You have missed the log x. Check. Okay. Clear? Okay. Perfect. Alright. Now let me give you some more derivatives of standard functions. So derivative of inverse trigonometric function. Derivative of inverse trigonometry function. Trigonometric. What am I doing? Bad handwriting, bad handwriting. Okay. So derivative of inverse trigonometric function. Okay. All right. Yes. So first derivative in this list is derivative of sine inverse x. D by dx of sine inverse x. Can anybody tell me? D by dx of sine inverse x is 1 upon square root 1 minus x square, where mod x is lying between mod x is lying between minus 1 and 1. Okay. First thing. Now second thing, derivative of cos inverse x. Okay. I have already told you, whenever there is a there will be a negative sign. Minus 1 upon square root 1 minus x square. So mod x is lying between 1 and minus 1. Okay. Alright. And then the third derivative is what? Third derivative is derivative of tan inverse x will be 1 upon 1 plus x square. All three formulas clear? Now the next three formulas will be, let me just write it down over here. Next three formulas will be fourth formula, which is cot. So again, d by dx of cot inverse x. Now can you spot the So this will be negative 1 upon 1 plus x square. Fifth, d by dx of sec inverse x, that is going to become 1 upon mod of x square root x square minus 1. And the sixth formula, can you see the sixth formula over here? So sixth formula will be d by dx of cosec inverse x will be what? Negative. Can you see co is there? So co means negative. So just the negative of this. So basically, if you remember three formulas, you have to remember sine inverse. Now cos inverse will be free. Remember sine inverse? Cos inverse is free. Remember tan inverse? Cot inverse is free. Remember sec inverse? Cosec inverse is free. Right? So what do we call it? Buy one, get one offer. Buy one, get one offer. Okay? This is something buy one, get one free. Okay, so you have to remember three formulas. The rest three are sorted because there is a co involved. Sine, cosine. Tan, cotangent. Sec, cosecant. Okay, like that. Got it? Yes, yes, yes. Understanding it? Okay. Alright. Now one question let me give you. Can anybody tell me the derivative of sine 2x plus sine inverse 2x plus 3? Differentiate it. Elementary problem. Y is equals to sine inverse 2x plus 3. Okay, shall we solve? Again, chain rule will be applicable. Dy by dx will be 1 upon square root 1 minus 2x plus 3 whole square. Derivative of 2x plus 3 will be 2. That's it. Done. Done, 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 done. Yes. Got it? Okay. So now we'll be moving towards the next problem, which is this. Let me give you one more problem. So this is the question, which is f of x is equals to 2 root x plus 1 sine inverse x plus 4 times root 1 minus x. Okay. And you have to figure out f dash x. Are we ready for it? Okay. Alright, now f dash x is equals to, now understand what is happening. This part is product of two function. So product rule will be applicable over here, and this is like a normal chain rule. Right, so 2 root x plus 1 sine inverse x. 2 is kept constant. Now root x plus 1 is first function, sine inverse x is second function. Now first function I am keeping it constant. Second function is sine inverse, which I am differentiating. So this is 1 upon square root 1 minus x square plus sine inverse x is kept constant this time, and derivative of root x plus 1 will be what? Who is going to tell me? Derivative of root x plus 1 will be 1 upon 2 root x plus 1. Now derivative of x plus 1 is x is 1, so I am not writing it. So this is finally going to give you what? 2 root x plus 1 upon root 1 minus x square plus, now 2, if you multiply it inside, 2 cancels, sine inverse x upon root x plus 1. So this is the first thing. Now the second thing, let's not forget, what about this? Chain rule. So for root 1 minus x, you know the derivative of root is 1 upon 2 root. So 4 upon 2 root 1 minus x, don't forget, 1 minus x will be differentiated again. So derivative of 1 minus x will be minus 1. So this is going to become minus 2. This is going to become minus 2 by root 1 minus x. So this is your final expression. Have a look. Let me know if that is clear. Okay, so what did we do? So understand, fx is equals to 2 root x plus 1 sine inverse x. So product of two functions is there. So here we will apply product rule. What about this? Here we'll be applying chain rule because this is one function inside other function. Okay, so composite function. Here we'll be applying product rule. So 2 root x plus 1. So 2 is kept constant. First, now product rule. First function will be kept constant. Derivative of second, that is derivative of sine inverse, is this. Plus, now this time sine inverse is constant, but root x plus 1 derivative is what? 1 upon 2 root x plus 1. This 2 is already outside, so just multiply 2, you will get this. Now come back to this chain rule. 4 root 1 minus x. 4 root 1 minus x. 4 is kept constant. Root 1 minus x derivative is 1 upon 2 root 1 minus x. Now 1 minus x will be differentiated again. You will get a minus 1. So if you cancel 2 2s are 4. So minus 2 will be here. So minus 2 upon root 1 minus x will be here. Okay. All right. Yes. Clear. Okay. Now let us come back to the next topic, which is derivative. Which is some standard substitution. So there are some standard substitutions, some standard substitution that we have to keep in mind. Substitution. Okay, what are those standard substitution? Let us understand. Okay, so if you ever see a square minus x square or a square minus x square square root, then your substitution would be what? Substitution. Then your substitution would be what? So substitution could be x equals to a sine theta or a cos theta. Understand what I am trying to say. See, a square minus x square. So you have how many trigonometric ratios? 6 trigonometric ratios, right? And you know what? Out of these 6 trigonometric ratios is try putting each and everything. If you put x equals to sine or cos, if you put x equals to a sine theta or a cos theta, then it will become a square will be common. It will become 1 minus sine square or 1 minus cos square. Now 1 minus sine square and 1 minus cos square both are something. Because 1 minus sine square is cos square. 1 minus cos square is sine square. Are you getting my point? So if I talk about this, so only these two substitution will work. If you try to substitute a tan theta, no, it's not gonna work. A cos theta, not gonna work. Not gonna. Rest everything is not going to work. So if you ask me, ma'am, is this very specific? Can't we put other? No, you can't. And you don't have to like remember. Just you have only 6 options, right? Just try putting and understand which identity is working for you. Now you are going to tell me. Now you know the drill. Now you know it that how we are substituting. Now you just tell me if you have expression of the form this or this. Okay, x square plus a square or square root x square plus a square. Now which trigonometric ratio will work? Sine will not work because 1 plus sine square is nothing. Sec and cosec will also not work because 1 plus cos square, 1 plus cosec square, 1 plus sec square is nothing. But 1 plus tan square or 1 plus cot square is something, right? So that's how it is. Now x square minus a square or x square minus a square. So this time sec and cosec will come into the picture. A sec theta or a cosec theta. Both will work. It depends. Okay. And the last but not the least, very important. If you see a minus x and a plus x both together outside or inside the root, then what will you do? Then you will substitute x equals to a cos theta. But why, ma'am? Like, okay, but why? So, the moment you will put x equals to a cos theta, now, what will happen? The numerator will become 1 minus cos theta and denominator will be 1 plus cos theta. And we have these two formulas. Do you remember 1 minus cos theta is equals to 2 sine square theta by 2. And 1 plus cos theta will be what? 2 cos square theta by 2. Yes, are you getting it? Are you understanding it? Shall I give you a few problems, guys? Shall I give you one problem? Okay, let's do one problem on it. Let's do one problem. Just one problem will clear all your concepts, okay? Let's do it. Y is equals to tan inverse square root 1 plus x square minus 1 upon x. Oops, hold on. No, not like this. Yeah. Upon x. This is your question which says that find dy by dx. when x belongs to -1 to 1. Now you do it, let me know. Oops, 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 oops. Sorry guys, sorry guys, sorry guys, sorry guys. Okay. I was on mute. Okay. Yes. So again, repeat. I guess I am audible now. So y is equals to tan inverse square root 1 plus x square minus 1 upon x. The moment you will see this 1 plus x square, let me just go back and tell you. 1 plus x square. So this is 1 plus x square. Put x equals to tan theta, right? You have to put x equals to tan theta. Now the moment you put x equals to tan theta, your x is tan theta. And here also you will put tan theta. So this is x square, tan square theta, tan theta. 1 plus tan square theta is what? Sec theta. And from here, just convert everything in terms of cos and sine. So this is 1 by cos, this is sine by cos. Take LCM, you will get this. Now 1 minus cos theta upon sine theta. Do you remember the formula? 1 minus cos theta is what? 2 sine square theta by 2. And sine theta is what? 2 sine theta by 2 cos theta by 2. Okay. Alright. Okay. Now understand, if you are forgetting these formulas, you can just, after the session gets over, just let me know in the comment section if you want a complete formula revision of trigonometry. I'll take a small session where we'll be revising each and everything of trigonometry. So if you're facing any difficulty in remembering the formula, I'll make sure that you do not forget it. Okay. So this is theta by 2. This is y. Now y is theta by 2. What is theta? Now understand, from here, theta is actually tan inverse x. So this is tan inverse x by 2. Now you just have to differentiate. So you know dy by dx will be what? 1 upon 2 is there. Derivative of tan inverse x will be 1 upon 1 plus x square. This is your final answer. Okay. Let me know. Yes, I guess Abhishek is asking, ma'am, how sec theta. Okay. So whenever I do, like, I will miss the step, you will be asking me, ma'am, explain this step. Okay. Ma'am, How sec theta minus 1? See, 1 plus tan square theta is what? Sec square theta. And there is a root. So square root of sec square theta is what? Square root of sec square theta is what? Okay. Are you getting it? Yes, Abhishek? 1 minus. Okay. Ma'am, how sec theta minus 1 to. Okay. Now take LCM. I guess you are asking how did you go from here to here. Sec theta is what? Ma'am, 1 upon cos theta minus 1 upon tan theta is what? Sin theta upon cos theta. Take LCM. Let me know if you are getting this or not. Take LCM. Okay. Is it clear? All right. Okay, now we have a few questions from your KCET examination PYQs. So let's start understanding now that we have understood the basics. We have understood how to apply the formulas are sorted. Now let us understand that how to apply the brains. Okay, let's solve a few questions of KCET previous year questions. Okay. Now can you see in this question, fx is there, gx is there. These are the two functions and they are giving gx. Gx is what? X minus 1 by x. Okay. And f of g of x, f of g of x, they are giving x cube minus 1 by x cube, and g of x they are giving as x minus 1 by x. Bindya is saying something for previous question. Yes, Bindya, you are saying correct. But square root is there, na? Bindya, 1 plus tan square theta is sec square theta. I agree, but you are missing that square root, right? So please understand there is a square root over here. So square root of sec square theta will be sec theta. So that's why sec theta minus 1 upon tan theta. Then, okay, you just convert everything in terms of cos and sine. Take LCM, you will get this. Apply the formula, solve it out, you will get it. Okay, alright. Now KCET 2023 PYQ, are we ready for it? Okay. Understand how we are going to do this problem. So first of all, understand what do question creator expects from us. Understand the question. fx and gx are given, gx is given, f of g of x is given, and he is asking, the creator, he or she is asking f dash x. Oh my goodness, f dash x. So f dash x will be able to understand if we have fx with us. So the whole problem is not about f dash x. The problem is about getting f of x. How to get f of x? Understand. Now what I'll be doing is, so gx is x minus 1 by x. So can I just write the right hand side of this thing, right hand side can be written down in terms of x minus 1 by x. Are you understanding? I will be manipulating this thing such that this thing is completely in terms of x minus 1 by x. Let me show you. F of g of x. Okay, ma'am. Now this is a cube minus b cube. Do you remember what is a cube minus b cube? So a cube minus b cube is a minus b. Correct? then we are having a square, then we are having plus ab, and we are having plus b square. Hold on, let me write down the formula for you. So whenever you see a cube minus b cube, it is going to become a minus b, then a square plus b square plus ab. Correct or not? This is formula. This is the formula I have applied. So this is a cube minus b cube. So here a cube is a is x, b is x, 1 upon x. So a minus b. Then we have a square plus b square plus ab. So x square plus 1 upon x square plus 1. Correct? So f of g of x is equals to x minus 1 by x. And now see, this x square plus 1 by x square can further be written down as x minus 1 by x whole square plus 2. And plus 1 was already there. Can I write this? Just tell me. X square plus 1 by x square. Let me just show you. X square plus 1 by x square can be written down as x minus 1 by x whole square minus 2. Yes or no? Sorry, plus 2. Yes or no? Approve or disapprove? Thumbs up or thumbs down? Do you understand this? So this x square plus 1 by x square is x minus 1 by x whole square plus 2. And there was additional plus 1 which I copy pasted. Okay. And now understand what I am trying to do. I am trying to replace x minus 1 by x as gx. I can do that. The moment I will see x minus 1 by x, I will be replacing it with g of x. Let's start doing that. So ma'am, f of g of x is equals to g of x. Okay. Then this is your g of x whole square plus 3. Right or wrong? And now the magic you can see. Can anybody tell me? Can anybody tell me? We have our f of x right in front of us. Gx can be replaced by t right here. Can you see? This gx will be replaced by t. So this will be f of t equals to t square plus 3. T square plus 3. So that means your f of t is coming out as t cube plus 3t. Now the question is done and dusted. T cube plus 3t. So your f of x is coming out as, finally your f of x is coming out as x cube plus 3x. So f dash x will be equals to 3x square plus 3. Oh ho ho. Alright. Clear. Let me know if you guys are having any doubts. Clear? Yes? Yes, Kush Mohit. So which answer is correct? You guys tell me. Which answer is correct? 3x square plus 3. Option D is absolutely correct. So did we kill KCET 2023 question? Are we killing this question? Yes or no? So last step. Abhishek is saying last step. Okay. So what we did, once again from top to bottom I will be telling you. See, gx is given. F of g of x is also given. And they are asking f dash x. That means the question is not about differentiation. The question is about how to extract f of x by manipulation. Okay. Alright. So now f of g of x is given. Now my brain says that why don't I convert this right hand side in terms of g of x. In terms, let's start writing this thing in terms of g of x. Right. And in terms of g of x means what? Writing this expression in terms of x minus 1 by x, right? Gx is this only. So writing this expression in terms of x minus 1 by x. So a cube minus b cube, a minus b, a square plus ab plus b square. Now x square plus 1 by x square can further be written down as x minus 1 by x whole square plus 2. So yes, x minus 1 by x whole square plus 2 plus 1. Okay. Now x minus 1 by x can be replaced by gx. So this is gx square plus 3. Now what you have to do is, in this last step, just replace wherever you find gx, just write it as t. So f of gx will be f of t. This is again one more t. t square plus 3. So t square plus 3. So t square plus 3. F of t is coming out as what? T square plus 3, or you can say t cube plus 3t. So by looking at this, can't I write f of x? Definitely that is going to be x cube plus 3x. Now differentiate. Differentiation was not even a challenge for us. The challenge was how to extract, how to obtain f of x. Okay. Alright. Perfect. Now let us move on to the next problem. Next problem was from KCET 2022. Okay. Again, not a very difficult problem. Do you guys want to try it out? Do you want to try it out? Yes? Okay. So now again, y is equals to this. So dy by dx, very easy question. This is not at all a tricky question, direct question. We have done these type of questions right in the session. So now again, product rule will be applicable over here. So 1 plus x square is kept constant. Derivative of tan inverse x is what? 1 upon 1 plus x square plus product rule I am applying. This time tan inverse x is kept constant. And derivative of 1 plus x square is 2x. Now this minus x will be differentiated as minus 1. So can you see 1 plus x square is getting cancelled out. So this is 1. This 1 and minus 1 getting cancelled out, 2x tan inverse x. Easy peasy lemon squeezy questions. So KCET, sometimes they can give you tough questions. Please understand, but not always. Not always. So the previous question I think that was a rank decider question. This is a rank decider question. Rank decider. Okay. So there will be a few questions which will be rank decider question. Not every person will be able to do this question. But this question, what do you think? Majority of you are able to do this. Right? So option A is absolutely right. Shall we move on to the next KCET PYQ, guys? Okay. Alright. This is again hell good of a question. Good question. Good question. Good. Please take more and more class. Don't worry. We are here to take classes only. Full day. Our full day job is what? Taking classes and making you feel more confident about the subject. Okay, that's the main agenda of my life is. I have found purpose of my life, guys. Okay. Alright. Now in this question they are giving f of 1 is 1. F dash 1 is 3. Okay. And we need to figure out the derivative of this at x equals to 1. Now like brutal chain rule will be applicable to this question. f of x plus fx whole square. Okay. So yes, start doing it. f of x. Start differentiating. Chain rule, remember? So always attack the outer function. F dash. Now this thing will be as it is. f of x. Correct? Now what you have to do is differentiate the internal function one more time. So f dash f of x. Now differentiate the internal function. This is the internal. One more time. F dash x and the last x will be differentiated. So you will get 1. So you have to stop it over here. Plus. Now can you see fx whole square this? So 2 will come in front. See, x raised to power n derivative is what? N x raised to power n minus 1. So this is fx square. 2 will come in front and f of x power 2 minus 1. So that is 1. Now fx will be differentiated. So f dash x and one more time that will be fx, right? Now put x equals to 1. Start putting it. F dash f of 1 bracket close. F dash f of 1 f dash 1 plus 2f of 1, so this is power 1, right? And this is f dash 1. Now both the things are given to you guys. See what is happening. F of 1 is given, f of 1 is 1. So the moment you put f of 1 right here, this is 1. So this will become f of 1. F dash is already outside. Now f of 1 again will be 1. So this is f dash 1. Are you getting it? Multiply. What about this? F of 1 is what? 1. So f dash, this f of 1 will be replaced by 1. So f dash 1. So this is again f dash 1. Okay. And there is one more f dash 1 which I am going to copy. So 3f dash 1 together. Can you see 3f dash 1 together? F dash 1 is 3. 3 multiply 3 multiply 3. So this is 27. Yes, Kushmohit. Oh, absolutely. Now what about this? 2f of 1. So this is going to become 2. F of 1 is what? 2 into 1 into 3. So this is plus 6 plus 6 plus 6. Absolutely 33 is correct. Have a look. Let me know. Yes, understanding it? Yes, Bindya, absolutely right. You guys are killing it, nailing it. KCET 2022 problem from the differentiation. You are getting it absolutely right. Okay. Alright, clear. Shall we move on to the next problem? Any doubts, any confusion? Now, KCET 2021 problem. Now, I'm not gonna solve it. Please, I just I'm keeping my pen here. Okay, but I have to do it right for you guys. Again, chain rule, dy by dx. So this 2 is there, power is 2. So 2 will come in front and cos x square will kept as it is. This is 2 minus 1. Now the internal function will be differentiated. So cos x square, again, one more time chain rule will be applicable, right? So cos, derivative of cos is minus sign, x square will be as it is. And now this time x square will be differentiated, so 2x, that's it. So this is going to become what? Minus 4x cos x square sin x square. Hold on, hello. Now this is something is getting created. Remember, sin theta, cos theta and a 2 will give us sin 2 theta. Same thing, x square, argument is same. So minus 2x, a 2 will be given over here. So this is 2 sin x square cos x square and that will be minus 2x sin 2x square. So minus 2x. Okay. So you guys are saying option A, which is not correct, guys. Not correct. Bindya, why you guys are saying option A? No. Not really. Option C is correct. You don't understand this. Minus 4 is not there. No, Puneet, all of you, Kushmohit, disappointing. I'm very disappointed, huh? So you understand, huh? How much, like, you must be thinking, KCET is easy. KCET is actually easy, but you know what? Majority of the students will make silly mistakes. That's why they will not be able to score, and that makes the KCET examination a little bit on tougher side. Okay, option C is correct, guys. Alright, now KCET 2019 question on your screen. Okay, let's start doing it. Okay, again, I'll give you a chance. Let's see how many of you are able to do it, how many of you are able to pull it off. KCET 2019, guys. Okay. Yes. So first of all, we are here to talk about derivative at x equals to pi by 2. Do you know the value of pi by 2? Approximately 1.57. That means this belongs to the interval between 1 to 2. Between 1 to 2, right? So GIF of x will become what when x belongs to 1 to 2? Can anybody tell me? GIF of x becomes what when x belongs to 1 to 2? So GIF of x becomes 1, right? When x becomes 1 to 2. Yes, Seema, absolutely. So this thing is f of x. Let me just for x belongs to 1 to 2, my fx will become x minus 1 minus cos x. And now you can peacefully differentiate. So this is going to be x derivative is 1 minus 0. Cos x derivative is what? Minus sin x. So this is going to become 1 plus sin x. F dash x. Now you can just go ahead and put pi by 2. So 1 plus sin pi by 2 is going to become 2. 2. Option A. Okay. Getting it? Understanding it? All right. Okay. So here comes by this question. We have come up towards the end of this session. So we have done a lot of questions from KCET. We have done a lot of elementary questions as well. The concept building question as well. And now I'll be taking the next session is going to be about differentiation only. So some more methods of differentiation, how to tackle a function where something raised to power something is there, logarithmic differentiation, implicit differentiation. Are there any short tricks to differentiate any complicated function, parametric function for that matter, higher order derivative, and of course KCET previous year question I'll be taking, okay. So this chapter, continuity and differentiability, you can expect 5 questions from this chapter alone. That's why I am taking a lot of sessions on this chapter, okay. So do not underestimate continuity and differentiability. 5 questions alone from this chapter, okay. And now if you want to like ask me any doubts regarding anything, if you have any suggestions, you can just join my Telegram channel, Namrata Jaisinghani. Alright, now you guys are talking about the timetable. Do not worry about the timetable. We'll be giving you timetable in a week. Within a week, we'll be having a meeting where we are going to discuss the full-fledged plan and we are going to share the timetable with you guys. Don't worry about it. Okay, just give us 1 week because you know what, we can't be just randomly giving, we just don't want to give randomly timetable. We want our planning, our strategy to be on point so that you can get under 1000 rank, okay. So do not worry about it. Like within a week, we'll be revealing the timetable, the whole schedule, so that you be consistent, you keep that in mind, okay, when exactly you can plan your studies accordingly, okay. So yes, we are going to do that. And on this note, this is me, your Ninja Ma'am, signing off. I'll see you all in the next video of differentiation. Do not miss that video because like 5 questions alone from this chapter will be there, okay. So bye bye, see you.